If you have ever looked at the specs of a microcontroller like Arduino or the ESP32, you have found a lot of confusing memory types like the SRAM, DRAM, IRAM, the RTC SRAM, or the flash. And what does all that mean? So most of the people think that a RAM is just a stick of RAM that you just insert in your PC. But inside a microcontroller, the thing is very clever and the memory is split into different parts according to their uses. So in this video, we are going to look into all the types of memories you are going to find in microcontrollers like the classic Arduino Uno or the ESP32 or even STM32. So by the end of this video, you will know what each type of memory does and why it's important for your project. But first, the big question is why your microcontrollers have different types of RAM but your PC just has one stick or one type of stick. So it all comes down to the power, space and job duties. So your PC has one big stick of DRAM or dynamic RAM. It's cheap, super flexible and holds gigabyte of data. If your Google Chrome or Safari needs a lot of memory, it just grabs from this one big pool of RAM. But here's the catch, the DRAM is a power hog. It consumes a lot of power, but it's not a problem for your PC because it's connected with AC voltage in your wall and obviously it has a power supply unit. And there's a plenty of space in your motherboard for this one big stick of RAM, which is equivalent to the 3 ESP32s in horizontal. So your microcontroller on the other hand runs on a small battery and which is capable for 1 day or 2 day or even for months of supply, but it just not capable to give enough power, right? So engineers turned the RAM into specialized pockets and separated the RAM into different parts so that it only turns on when the specific task is needed, that type of RAM. Plus your microcontroller is very small, like the width of your 2 fingers, or if your finger is big, just one. There is just less room for a dedicated chip for a RAM. So everything has to be squeezed in just this tiny piece of board. So each memory type is just built for its specific jobs for these microcontrollers. Now that we understand why, so let's just look at the 3 main memory types every microcontroller has. The flash. Think of it like a notebook. So this is your permanent storage. So when you upload the code, this just lives in the flash memory. Think of it like a notebook that holds all your information or all your code even after the power is off. So when you upload your code in the Arduino or the sketch you built in this Arduino, it just stays in the flash memory. So flash is non-volatile, which means even when you just unplug your power source or turn off your battery, it just stays permanent in your flash memory, all the codes you just wrote in this Arduino board. So it's your microcontroller's hard drive. So the next is SRAM or static RAM. Think of it like the desk you are working on. So SRAM is your main workspace. So this is where all your variables, the stack and the heap stays when you run this program in your microcontroller. So it's the desk where all the active things happen. SRAM is super fast and very efficient, but it's volatile. So you turn off the power and everything on the SRAM just disappears. That's why your variables just reset when you turn the board again or just press the reset button of your microcontroller. So finally, we have EEPROM or EEPROM. So this is electrically erasable programmable read-only ROM. So think of it like the filing cabinet. It's just like the flash, meaning this is non-volatile, but you can change individual bytes. So EEPROM is perfect for settings like your Wi-Fi SSID or password or your calibration values. So not all the modern microcontrollers use the EEPROMs, like ESP32 doesn't have any EEPROMs, but this uses the flash emulation similarly to the EEPROM, but the concept is very similar. It's just the same thing that the EEPROM does, that it just stores the calibration values or the Wi-Fi SSIDs, like the small memory just store your configuration data. So now let's answer the very common question that where is the RAM physically located in this microcontrollers or like this microcontrollers. So most of the microcontrollers RAM is directly built in on this chip or like on this chip. So these are internal. So these RAMs are directly built in along with this processor or the chip. So if you could just see the chip of a microcontroller with a microscope, you would be able to see the SRAM chip along with the CPU cores of the microcontroller. So this is why the SRAM is very fast, because it's just next to the microcontroller CPU core. But it's expensive to make, and that's why microcontrollers just have a tiny bit of SRAMs. So some microcontrollers also support external RAMs. This is a separate chip that just connects to the board and directly connect to the MCU unit using the wires, also known as traces. So external RAM like the PSRAM just built on the board of ESP32. This PSRAM is cheaper and slow because this just there's just a lot of distance between the CPU and the RAM, but it's much cheaper to add the big external RAM onto the board than just using the RAM on the microcontroller unit or the MCU. So now let's look at the most powerful board and also beginner friendly, the ESP32. This chip takes the memory management to the next level by splitting the memory into different parts according to their tasks and managing the battery. So the ESP32 has DRAM, IRAM, RTC SRAM and PSRAM. First is IRAM, the instruction RAM. So this is a special section of memory that is used for the codes that need to run very fast, like interrupt handlers or the time critical functions. So normally your code runs from the flash, which is usually slower. But if you need a function to run in microseconds, you just store it in the IRAM. So it's like just putting the most important items of your room into a shelf rather than just on a drawer, on a locked drawer or on an almirah. This is the normal working memory for all the variables and all your runtime data. It's the ESP32's main working space. But here's the interesting thing about ESP32, that the DRAM or the data RAM is just like the same as the SRAM or the static RAM. They just call it DRAM, just distinguish it from the IRAM of this board. And another thing, you just don't mess it up with the dynamic RAM that your PC has on the motherboard. The DRAM on ESP32 is the data RAM, not the dynamic RAM of your PC. Then we have RTC SRAM. This is the real-time clock SRAM. So this is a tiny ultra low power memory that just stays alive even when your microcontroller just goes to the deep sleep. It's just like a sticky note that remembers the time, date, or the waking up alarm when the chip is almost in the deep sleep state. So it almost uses no electricity, so it's perfect for your battery powered projects. So finally, some ESP32s come with extra RAM, that is PSRAM or the pseudo SRAM, like the boards that has the camera or like the audio outputs. This comes with the PSRAMs. This is just like the extra memory that comes with the board for your big sized projects. It's slower than the internal RAM, but it's huge of size. So it's perfect for audio output or the camera streams or like the complex graphics for your projects. It's like pulling up an extra table beside your main table for extra works you have to do. Now let's look into STM32 microcontrollers. They have their own set of specialized memory for speed and persistence. So the first is CCM RAM or TCM RAM. They're the fastest ones. Some STM32 chips just include the CCM RAM or TCM RAM for performance enhanced data or codes. So think of it like a VIP route for most of your important data. It's directly connected to the CPU cores, and this is the reason that they're faster than the SRAMs itself. And then there comes the backup SRAM. This is a small section of memory that can retain data when your main system is powered down, as long as you have the backup battery turned or connected with your microcontroller. It's perfect for storing your critical system data or like the calibration data that you just don't want to lose if your power is turned off or you have a power outage on your microcontroller unit. So we have explained all the memory types. So now let's all together see all the memory types so you can compare each one with the other. So here's how it all fits together. At the top you have flash, the notebook that stores your program. In the middle you have SRAM, the disk where all the active work happens, split into IRAM for code and DRAM for data on some chips. Then you have specialized memory types, RTC SRAM for low powered timekeeping, PSRAM for extra space, and TCM or CCM for speed. Different microcontrollers use different combinations of these memory types depending on what they are designed for, and Arduino Uno keeps it simple with flash, SRAM, and EEPROM, and ESP32 adds more specialized RAM for performance and power saving. And an STM32 gives you even more options for speed and data persistence. All the memory types are explained, and now in the next time you just see the specs of a microcontroller, you know exactly what all types of memory the microcontrollers have, work on how they work, and which one you will need the most. So just let me know in the comment section which type of microcontroller memory surprised you the most. And if you just found this video helpful, just like, share and subscribe to this channel, and thank you very much for watching. I will just meet you in the next video, so thank you very much.